Hey folks, it's me, and this is video 2 of our elementary statistics where we are examining data sets. There we go. So we're going to be looking at a number of important aspects of statistics, including the mean, and then one of the more challenging ones, which is the median and quartiles. And we're going to be looking at them from both the geometric and the algebraic forms, which I usually consider better. And we're also going to be looking at the mean absolute deviation, and finally the box plot. Now, I'm going to have some terms that you may not be familiar with, so I want you to write these on a piece of paper. So in this case, when you see n, that means the numbers in a set. And the x actually means each one of the numbers. So in this case, we've got x1, x2, x3, and x4. And that little subscript is usually, I write it with an I. And then finally, this is a sum. Our 3 exercises will be with 7, 8, and 9 sets of numbers. So let's get started. Our first problem, we have 7 numbers, and we begin with 14, 9, 11, 5, 17, 15, and 6. And from these we want 4 things: the mean, the median, the interquartile range, and the mean absolute deviation. So to calculate the mean, let's go ahead and write down this formula. And this just means 1 over n numbers in a set times the sum of each of the individual x's. I know the fancy writing is off-putting, but you may as well get used to it because you're going to see it a lot in the future. Okay, so we sum these up. That gives us 23, 16, and 32, and 6. And that's 77. And now our 1 over n of this amount is just 1 over, and this is n equals 7, so that's 1 over 7 times 77, which means that our mean is 11. Okay, now let's move to our median and quartiles. And in this case, we're going to do it the simple way, which is the geometric way, as we did in our previous video. And we're going to go ahead and first we have to order our set. It's 5, 6, 9, 11, 14, 15, and 17. Okay, and then we split it into halves. So our first split must give us equal numbers on each side, and we have to split it right down the number. This way we'll get 3 on this side and 3 on the other side. Okay, and next we split it again. This split down the 6 and the 15 will now give us 1 number in each one of these groups. It seems kind of weird when you do it because sometimes you split down a number, sometimes you split between, but if you do it enough times, it should kind of start to sink in. Okay, now let's go ahead and get our interquartile range, and that's just quartile 3 minus quartile 1, the distance between them. So that's 15 minus 6, and that's 9. Finally, our mean absolute deviation, and that has this little formula here, which is 1 over n, again like the other one, but this is the sum of the absolute value of the mean, which is a little Greek symbol we call mu, and each one of the x's. Okay, so I know it looks fancy, but once we do it, you'll see what it means. So we're going to do this first part. That's going to be 11 minus 5. Remember, the mean is 11, so 5, 6, 9, 11. And then we have 2, 0, and then we have 11, 14, 15, and 17. And here we have 3, 4, and 6. Now let's add all of these up. 13 and 13 is 26. And then let's do this, the 1 over n, which is 1/7 times 26. So that's 26 divided by 7, and we get 3 and 21, and we have 50, 49, 7, okay, 10, 7, 30, 28, that's enough. 3.714. Okay. So that was the easy one. Now let's bump it up a little harder. So for problem 2, we have the set of 8, 4, 9, 12, 14, 20, 10, and 5. And we again want the mean, the median, the interquartile range, and the mean absolute deviation. Now, for the mean, once again, let's look at that formula. And I keep pasting it here because you're going to be seeing it a lot in the future, like I said, so you may as well get used to how we will write our instructions in math. Let's go ahead and add these all up. Okay, so 8 and 4 is 12, 9 and 12 is 21, 14 and 20 is 34, 10 and 5 is 15. These two add up to 33, and these two add up to 49. And then this gives us 82. And we divide it by n, which is 8. So this is 8 into 82, and that's 1, 2, 0, and that's 0.25. So we got 10.25. Okay. Now let's do the quartiles. Now the quartiles, I'm going to show you a new way. So but I'm going to compare it. Okay. And it's very important because the new way is actually better. So the first way is the geometric. The second is the algebraic. Now you should learn both because unfortunately some of your math teachers only know the geometric and they will actually write you wrong for the algebraic. They will not understand why. I might later write a proof as to why the algebraic works, but in the real world, in statistics, we actually use the algebraic. So here we are splitting our numbers, just like before. We split them so that we get even numbers. Notice that we've got 2 in each one of these quartiles. So our first quartile is the average between 5 and 8, and that's 6.5. And here we've got 9 and 10, and that's 9.5. We've got 12 and 14, that's 13. Now, let's move on to the algebraic. So first off, let me give you the formula. Write down this formula. That's the quartile number is the number over 4 times n plus 1. I know every time you see a new formula, it looks scary because you've never seen it. But you got to do it a few times and it starts to sink in. So, first thought, quartile 1, that's 1/4. And then 8 plus 1, so that's 1/4 of 9, that's 9/4. So that's 2.25. We need both those parts, okay? So we have 2/4 times 9, that's 9/2 and 4.5. We have 3/4 times 9, which is 27/4. And that's 9.75. Okay, now, our next part, we go ahead and set up each one of the quartiles as such. This begins with a 2 and the 0.25. Now these two numbers here, we split the 0.25 and then we added 0.75. We get these two numbers here from 2 and 3, okay? And we cross multiply. Now, it seems weird. There's logic behind it. But right now I'm just showing you the mechanics, okay? You might actually understand it if you think about it. So let's do this again, okay? Our quartile 2 has a 4 and then a 0.5. And then we get our 4th and 5th values, which are 9 and 10. We cross multiply again, and we get 9.5. Okay, and then our quartile 3, let's do it again, and this is at 9. And it's 0.75 and 0.25, so we get values 9 and 10. Okay, and we cross multiply so that we get 3 and 10.5, that's 13.5. Okay, now notice our values at our edges are different, and this is because of an important problem with the geometric method, and later on it even gets worse. Okay, so let's do our interquartile here, which is Q3 minus Q1. That's going to give us 7.75. Okay, let's move on to our mean absolute deviation. And once again, the formula is 1 over n. This is different from the mean. Remember, it's similar in some ways, but it's different because now we're the mean times the x value. So the mean is 10.25. So let's go ahead and set up our sums, okay, or our subtractions, whatever you want to call them. 25, 4, 5, 8, and minus 9. Okay, and then we set up 10 minus 10, and then minus 12, and 25 minus 14, and minus 20. Okay, now for our first one, we got 6.25, and then this should be 5.25, 2.25, and 1.25. This is 0.25. Now look at this. Do not just follow the pattern. This is different, and it's a pitfall. This is 1.75, 3.75, and 9.75. Remember that pitfall. I've seen a lot of people make that mistake where they keep following that 0.25. Don't be one of them. Okay, so we add these up. We got 0, 2, 1, that's 15. Okay, and then we've got 0, 5, okay, 15.5. And we add these up, 30.5 times 1/8. So then it is 8 into 30.5. That's 3 and 24. Okay, and then that's 6.5. Okay, and that gives us 8, 6, 4, 10. Okay, 3.8, 1, 2, 5. Okay, so that's 3.8125. Good. Now let's go on to the more challenging one. And our numbers are 5, 3, 14, 21, 3, 7, 16, 12, and 11. And our mean, our median, interquartile, mean absolute deviation, and our box plot. So let's first begin with the mean, again, as before. So we have 1 over n times the sum of the x's. So 5 and 3 is 8, 14 and 21 is 35, 7 is 10, 16 and 12 is 28, and 11. Okay, and we have 9 numbers, of course, so that's 1/9. And then we have 8, 35, and 10, that's 53, 28 and 11, that's 39. And this gives us a sum of 92. So let's see, 9 into 92, and that's 1, 9, 2, 0, okay, 0.2, that's 18, 2, and you notice this is going to be 2 forever. So we're just going to stop here. So our mean is 10.22 forever. Okay, now let's go on to the quartiles, okay, and our median. So first of all, we're going to do the geometric, the simpler one, and we're going to do the algebraic in just a bit. So let's set them in order. 3, 3, 5, 7, 11, 12, 14, 16, and 21. So geometrically, we split them down the middle, and that means we cut 11 in half. That becomes median, or quartile 2. We do this again. There's a quartile 1 and quartile 3, and we should now have 2, 2, 2. Remember, when we cut a number, we don't include it in our count. That's part, if you notice, that doesn't make too perfect sense, and that's part of why we use the algebraic method instead later, because it's kind of a cheat. It kind of works, but not that well. So our first quartile is 4, second quartile is the number we split, and our third quartile is the average between 14 and 16, which is 15. Good. Let's go ahead and move on to the algebraic now. So, and let's remember our formula, and that is the quartile number equals the number over 4 times n plus 1. And if you think about it, that n plus 1 should make sense if you start off with 2 numbers. Think about it and try it out. it shouldn't be that hard. So first quartile times 4 times 10, so that's 2.5. Our second quartile is 2/4 times 10, which is 5. And our third quartile is 3/4 times 10, which is 7.5. So we want the 2.5, the fifth, and the 7.5 numbers. Okay, so let's see, 0.5, 0.5. This is the exact number, so we just we keep it as it is. Okay, and our seventh, and this is 0.5 and 0.5. Okay, and we do the little, we carry numbers 2 and 3, and then here we have 14 and 16. So, okay, let's cross multiply. We got 7 and 8, that is 15. And then we've got 1.5 and 2.5, and that gives us 4. And that's just the number that we split, so we got 11, 4, and 15. Okay, so notice this time we actually got the same values as the geometric. As I said in my notes right there, that if you're paying attention, they will equal the same. So our interquartiles, they are going to be quite simple. It's 11. Now let's move on to the mean absolute deviation. Okay, so our formula is 1 over n times the sum of mu minus xi. Okay, and that's what the formula actually looks like very, very formally. And the mu here is 10.22. Okay, so let's write up our sums. 1022 minus 3, 1022 minus 3, 1022 minus 5, 1022 minus 7, 1022 minus 11 equals 1022, no, okay, 7.22s, 5.22, and 3.22. And here's the pitfall zone when the number changes. Remember, when your value changes to more or less than the mean, you're going to get a different amount. We got 0.78, then it's 1022 minus 12. That's 1.78, but okay, let's continue. 14, 16, and 21. Okay, this is 1.78. And this is 3.78, 5.78, and 10.78. Okay, now let's sum these all up. So this one is 2, 4, 6, 8, and 8, and 16. Okay, and then we have 2, 4, 7, 16 again. Okay, and then 7, 14, 15, 20, 23. So it's 23, yeah, 23. Okay, so that's 18, 32, 3 times 7, 14, 21, 28, 29, 30, 31. Okay, and then that's 8, 9, 10, 11, 12, 22. Okay, 22, yeah. Yeah, 22.12. Okay, now we add these two up. That's 6 and 2 is 8. That's 7. Okay, and then that's a 5, 45.78. Okay, so now we have our sum, and let's divide this by 9. So 9 and 45, so that's 5, that's 45. Okay, and then that's 7, and that's going to be 0. Okay, and then we're going to 78. Okay, and that's going to be 8. And that's 72. And that's going to be 6. That's 60. So that's 54. Okay, and 40, and we'll just leave it at that. Okay, so our mean absolute deviation is 5.09. Okay. Now let's go for our box plot. And this is the simplest one, that's why I left it for last. But our box plot describes how our numbers are distributed. And although we just have a very small count of numbers, because really 9 numbers is too little. In real statistics, you'll be dealing with hundreds or thousands. That's where box plots really count, because they're telling you roughly where the majority of your values are falling. Where your upper and your lower quartiles are falling. This is your lower value. Okay, and then this is your median, and this is your third quartile. And here is our lowest value, which is 3, and our highest value is 21. And we draw our box. Here we go. And then we do our little lines. And that's showing us where most of our values are falling, which is between these quartiles. So this should give you an idea of roughly where everything is bunching up. Okay, so here's 3, 4, 11, 15, and 21. Okay, so hopefully that wasn't a little too fast. I tried to slow down in the second half, and there's a lot of things that I kept out. There's a lot of theory that I skipped, and I apologize. If you really want me to cover theory, please let me know. What I really wanted you to do is follow along with me on a piece of paper, because really most of this will seem like it's just a foreign language until you do it yourself. So that's it for now. Any questions, let me know.